Chapter 6 Chemical Reactions. This theme will enable students to understand that several oxides, carbonates and hydrates on heating are converted to other compounds. Oxides of metals and non-metals have basic and acidic character respectively. They will also realize and appreciate that there are different types of reactions such as combination, decomposition, displacement, double displacement, exothermic and endothermic reactions. Learning outcomes. After studying this chapter, students will be able to describe different types of chemical reactions with examples, identify the different types of chemical reactions, identify different oxides as basic, acidic, amphoteric and neutral, explain the effect of heat on oxides and some metals. Important terms and their definitions. Catalyst. A catalyst is a substance that changes the speed or rate of a reaction but itself remains unchanged. Effervescence. When gas bubbles are formed, usually with a hissing sound due to a reaction, the phenomena is called effervescence. Electrolysis. A process in which a substance is decomposed or broken down into smaller fractions by passing electric current through it is called electrolysis. Cathode. The electrode connected to the negative pole is called the cathode. Anode. The electrode connected to the positive pole is called anode. Reduction. The addition of hydrogen to or removal of oxygen from a substance is called reduction. Oxidation. The addition of oxygen to or removal of hydrogen from a substance is called oxidation. Chemical reaction. A chemical reaction occurs when a chemical change takes place in our universe, system and surrounding. System is the part of universe in which reactions can take place. Surrounding is the remaining part of universe except system. Let us consider a few examples of process in which reactions take place in our daily life. Cooking of food is done, carbohydrates and protein molecules, digestion of food in our body, formation of food by plants due to the photosynthesis process, exchange of gases during the respiration, burning of fuel, curdling of milk, rusting of iron. In all such situations, these substances lose their identity and nature and form a new substance by a chemical change. For example, if we burn a fuel in the presence of air, it loses its previous identity, carbon, and changes into carbon dioxide, CO2, that is C fuel plus O2 air is CO2, carbon dioxide. We can explain it by another example. When we add a few amount of curd into a warm milk, it converts into curd. In this process, carbohydrate of milk, that is lactose, turns into lactic acid, curd, by the presence of lactobacillus bacteria. Hence, we can define such a process in which a substance changes into another substance with its different chemical properties is called chemical change. The process in which chemical change takes place is called a chemical reaction. In a chemical reaction, rearrangement of atoms take place with changing their chemical properties such as CS carbon plus O2G oxygen is CO2G carbon dioxide. A carbonic compound burns in the presence of air oxygen and forms CO2. In this reaction, carbon and oxygen rearrange their atoms and form carbon dioxide, which is different in chemical property from carbon and oxygen. We will now discuss about reactants and products. The substances which take place in a chemical reaction, different in their chemical property, are called reactants. The new substances produced as a result of chemical reaction by rearrangement of the atoms are called products. For example, C plus O2 reactants is CO2 product. Types of chemical reactions. Chemical reactions are of the following types: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, redox reactions, oxidation and reduction reactions. Combination reactions. Those reactions in which two or more substances like elements or compounds combine to form a single substance or product are called combination reactions. For example, X plus Y is XY. Examples of combination reactions. Burning of carbonic compound. When carbonic compounds burn in the presence of air, they form a single product, that is carbon dioxide, CO2 gas. CS coal or wood plus O2G oxygen from air is CO2G carbon dioxide. Formation of water. When hydrogen gas reacts with oxygen gas in an electrolytic condition, then water is formed, which is a single product. Formation of common salt NaCl. When molten sodium metal combines with dry chlorine gas, it gives sodium chloride or common salt NaCl. Decomposition reactions. Those reactions in which a compound breaks up or splits up into two or more simpler substances are called decomposition reactions. That is, XY is X plus Y. These reactions are just opposite of the combination reactions. Examples of decomposition. Decomposition of ferrous sulfate crystals into ferric oxide, sulfur dioxide and sulfur trioxide in activity 6.2. Decomposition reactions further can be classified into following types: thermal decomposition reaction, electrolytic decomposition reaction, photochemical decomposition reaction. Thermal decomposition reactions. Decomposition of reactants carried out by heating is called thermal decomposition reaction. Examples of thermal decomposition reactions: decomposition of lead nitrate. On heating, lead nitrate decomposes into lead oxide, nitrogen dioxide and oxygen. Decomposition of sodium bicarbonate NaHCO3. On heating, sodium bicarbonate decomposes into sodium carbonate, water and carbon dioxide. Decomposition of calcium carbonate CaCO3. On heating, calcium carbonate or limestone decomposes into quicklime or calcium oxide and carbon dioxide. Electrolytic decomposition reactions. Decomposition of compound takes place when an electric current is passed through it in its molten state. This is called electrolytic decomposition reaction. Examples of electrolytic decomposition reactions: decomposition of water into hydrogen and oxygen. By the process of electrolysis, water decomposes into H2 and O2. Decomposition of sodium chloride in molten state. Molten sodium chloride decomposes into sodium and chlorine by the process of electrolysis. Photochemical decomposition reactions. Decomposition of a compound takes place on absorption of light. This is called photochemical decomposition reaction and the process is called Examples of photochemical decomposition reactions: decomposition of silver chloride. Silver chloride decomposes into silver and chlorine in the presence of light. Decomposition of silver bromide. Just like silver chloride, silver bromide decomposes into silver and bromine in the presence of light. Displacement reactions. The reactions in which one atom or radical group of atoms of a compound is displaced or replaced by another atom or radical are called displacement reactions or single displacement reactions. Reactions can be generalized as A plus BC is B plus AC. In the displacement reactions, more reactive metal displaces the less reactive metal. The order of reactivity. The arrangement of metals according to their reactivity in decreasing order. More reactive, least reactive. Potassium K, sodium Na, calcium Ca, magnesium Mg, aluminum Al, zinc Zn, iron Fe, lead Pb, copper Cu, silver Ag, gold Au, platinum Pt, decreasing reactivity. Explanation of displacement reactions. In this reaction, magnesium is more reactive than copper. Due to it, magnesium displaces the copper and forms the magnesium sulfate, and copper metal is free from copper sulfate compound. Examples of displacement reactions: Displacement of copper from a solution of copper sulfate by zinc. When a zinc strip placed in copper sulfate solution, a reddish brown copper metal deposits on its strip and blue color solution of copper sulfate changes into colorless solution or solution of zinc sulfate. Displacement of copper from copper sulfate by magnesium. When a piece of magnesium metal is placed in copper sulfate solution, the blue color of copper sulfate solution changes into colorless solution of magnesium sulfate MgSO4. Displacement of silver from silver nitrate solution by copper. When a copper strip is placed in solution of silver nitrate, grayish white silver metal deposits on its strip and solution of silver nitrate AgNO3 turns blue solution of copper nitrate CuNO3 too. Double displacement reactions. Those reactions in which compounds react by an exchange of ions to form two new compounds are called double displacement reactions. In other words, those reactions in which anions and cations of two different molecules are exchanged, forming two entirely different compounds, are called double displacement reactions. Types of double displacement reaction: precipitation reactions, neutralization reactions. Precipitation reactions. Those chemical reactions in which aqueous solution of two compounds are mixed together form an insoluble compound or precipitate which is separated by filtration are called precipitation reactions. For example, double displacement reaction in between silver nitrate and sodium chloride. When silver nitrate solution AgNO3 is added to sodium chloride NaCl solution, a white precipitate of silver chloride AgCl is formed. Double displacement reaction in between copper sulfate and hydrogen sulfide. On passing hydrogen sulfide gas through an aqueous solution of copper sulfate CuSO4, a black precipitate of copper sulfide is formed. Neutralization reactions. When acids and bases are mixed together by exchanging their radicals, form salt, compound and water. Since the products formed due to this reaction are neutral to litmus, the reaction is called neutralization reaction. For example, double displacement reaction in between sodium hydroxide and hydrochloric acid. When aqueous solutions of sodium hydroxide and hydrochloric acid are mixed together, sodium chloride salt and water are formed. Double displacement reaction in between potassium hydroxide and nitric acid. When potassium hydroxide reacts with nitric acid, potassium nitrate and water are formed. Redox reactions or oxidation and reduction. Redox makes up of two words, red plus ox. Red is reduction, ox is oxidation. Redox reaction, the reaction in which reduction as well as oxidation reactions take place simultaneously, is called redox reaction. Oxidation reaction, the reaction in which a substance gains oxygen or loses hydrogen during reaction is called oxidation reaction. In other words, addition of oxygen or removal of hydrogen is called oxidation reaction. Examples: reduction reaction. The reaction in which a substance gains hydrogen or loses oxygen is called reduction reactions. In other words, addition of hydrogen or removal of oxygen is called reduction reaction. Examples: oxidizing agent or oxidant. A substance which gives oxygen or removes hydrogen is called oxidizing agent, like O2 is an oxidant or oxidizing agent because it causes the oxidation of other substance. Example: in this example, O2 acts as oxidizing agent because it causes the oxidation of C. Similarly, Cl2 also acts as an oxidizing agent. Reducing agent or reductant. A substance which provides hydrogen or removes oxygen is called reducing agent or reductant. For example, H2, H2S, C and CO2. These substances act as reducing agents because they bring about reduction reactions. Example: some chemical reactions have required energy for breaking the bond of reactant as compared to product, and some have not. On behalf of their energy requirement, chemical reactions are differentiated into two types: chemical reaction, exothermic reaction, endothermic reaction. Exothermic reaction. Exothermic word is made up of two words, exo plus therm. Exo, exit, and therm, heat. That reaction in which the energy is required by reactant to break the bond is less than product to form the bond, and that is evolved during the reaction is called exothermic reaction. Examples: nuclear fission, mixing water with strong acid, mixing water with calcium chloride, CaCl2. Endothermic reaction. Endothermic word is made up of two words, endo plus therm, endo in, and therm, heat. That reaction in which the energy is required by reactant to break the bond is more than the product to form the bond, and heat is required during the reaction is called endothermic reaction. For example, mixing water and ammonium nitrate, reaction of barium hydroxide and octahydrated crystals BaOH2 8H2O with dry ammonium chloride NH2. Catalytic reactions. Catalytic reactions are those reactions in which the rate of a chemical reaction is altered, accelerated or slowed down with the mere presence of an external substance, and this external substance does not undergo any change in its mass and chemical constitution, and thus it remains unchanged in the end of the reaction. Such a substance which does not take part itself in the reaction but only increases or decreases the rate is called catalyst. For example, when potassium chlorate KClO3 is heated, it melts at about 340 degrees centigrade, but no oxygen comes out. It will decompose to evolve oxygen only around 600 degrees centigrade. It is found, however, that the addition of a little manganese dioxide MnO2 to it causes it to decompose even below its melting point, and after the decomposition is over, no change is observed in the quantity or composition of manganese dioxide. Here, MnO2 acts as a catalyst. Hydrogen peroxide H2O2 decomposes easily into water and oxygen, but the presence of phosphoric acid H3PO4 decreases its rate of decomposition. In this reaction, phosphoric acid thus acts as a catalyst. The most efficient and elegantly designed catalysts are natural ones known as enzymes. Natural enzymes speed a myriad of biochemical reactions. Enzymes are used in human body which function as catalyst. Enzymes are also used in a variety of chemical processes, mainly in the manufacture of food and drinks. Minerals known as zeolites have been found to be very useful catalysts for organic reactions, particularly those used to produce petrochemicals. Zeolites mainly contains alumina, aluminum oxide Al2O3, silica and water. Reversible reactions. Chemical reactions in which products formed recombine to give the original reactants are called reversible reactions. A reversible reaction is represented by a double arrow. Reactivity series. We know that metals form cations by losing electrons from the outermost shell of its atoms. If a metal loses electrons more easily than the other, it will form ions more rapidly, or it will be more reactive than that which does not lose electron easily. The metals, when listed according to their electron releasing tendency, the list is called reactivity series. In other words, the series of metals arranged in a vertical column in order of the decreasing reactivity is called reactivity series. In a reactivity series, the most reactive metal is placed at the top and the least reactive metal at the bottom.
Reactivity series of metals.
Characteristics of reactivity series. The most reactive metal is placed at the top and the least reactive metal is placed at the bottom of the table. Metals present above the hydrogen in reactivity series can displace hydrogen from dilute acids. A metal can displace the metals placed below it in the reactivity series. Metals present at the top are more electropositive, so they will occur in combined or compound form only in nature. Metals at the bottom are less reactive and do not react easily, so they may present in free state in nature. Classification of oxides. Oxides are chemical compounds with one or more oxygen atoms combined with another element. Example Li2O. Oxides are binary compounds of oxygen with another element. Example CO2, SO2, CaO, CO, ZnO, BaO2 and H2O, etc. These are termed as oxides because here oxygen is in combination with only one element. Based on their acid-base characteristics, oxides are classified as acidic, basic, amphoteric or neural. An oxide that combines with water to give an acid is termed as an acidic oxide. The oxide that gives a base in water is known as a basic oxide. An amphoteric solution is a substance that can chemically react as either acid or base. However, it is also possible for an oxide to be neither acidic nor basic, but it is a neutral oxide. There are different properties which help distinguish between the three types of oxides. The term anhydride without water refers to compounds that assimilate H2O to form either an acid or a base upon the addition of water. Acidic oxides. Acidic oxides are the oxides of non-metals, groups 14 to 17, and these acid anhydrides form acids with water. Sulfurous acid SO2 plus H2O, H2SO3. Sulfuric acid SO3 plus H2O is H2SO4. Carbonic acid CO2 plus H2O is H2CO3. Acidic oxides are known as acid anhydrides. Example, sulfur dioxide is a sulfurous anhydride and sulfur trioxide is a sulfuric anhydride, and when combined with bases they produce salts. Example, SO2 plus 2NaOH is Na2SO3 plus H2O. Basic oxides. Generally, group 1 and group 2 elements form bases called basic anhydrides or basic oxides. Example, K2OS plus H2OL is 2KOHAQ. Basic oxides are the oxides of metals. If soluble in water, they react with water to produce hydroxides or alkalis. Example, these metallic oxides are known as basic anhydrides. They react with acids to produce salts. Example, amphoteric oxide. An amphoteric solution is a substance that can chemically react as either acid or base. For example, when HSO4 reacts with water, it will make both hydroxide and hydronium ions. Amphoteric oxides exhibit both basic as well as acidic properties. When they react with an acid, they produce salt and water, showing basic properties. When reacting with alkalis, they form salt and water, showing acidic properties. For example, ZnO exhibits basic behavior with HCl and acidic behavior with NaOH. Similarly, Al2O3 exhibits basic behavior with H2SO4 and acidic behavior with NaOH. Neutral oxides. Neutral oxides show neither basic nor acidic properties and hence do not form salts when reacted with acids or bases. Example, carbon monoxide, CO, nitrous oxide, N2O, nitric oxide, NO, etc. are neutral. Chapter 7.